Saxon Algebra 1, Lesson 65. Greetings, students. We're getting up there, Lesson 65. That's a lot of lessons that we have accomplished. Let me offer you a pat on the back. Pat yourself on the back. I can't extend it virtually. Pat yourself on the back. Great job. We are making huge amounts of progress, and you're doing great. Lesson 65, we're going to learn to add radicals. Now, just as a reminder, last time we learned that we could multiply radicals and we could move them, whoops, that should be an N. We could move them in and out of their little houses however we wanted, right? We had a three little pigs metaphor going, and they could stay separately or they could run together, whichever they preferred, right? And if they were together, we could move them apart. It's fine, right? However, that was multiplying. Today, we are adding, and it's a whole different set of rules. Oh, math, why must you be the way you are? Let me show you what the rule is for adding. It's not hard, it's just different. Add. The rule for adding radicals is that we can only add them if they match. Square root of 2, square root of 2, square root of 2. It's kind of like variables, really, if you think about it, right? In order to add, if this was 4x minus 5x plus 12x, we could combine them because they were all x's, right? If one of those was a y, he could not join the club. Same thing with radicals. As long as they're all 2's, we can combine them. If one of these was, say, a 3, no, he can't join the club. So once we determine that all the radicals match, then we can just turn our attention to the coefficients and the signs in front of them and combine them. 4 minus 5 is -1, plus 12 is 11 times the square root of 2. That's the answer. Oh, that was an easy one, right? Let's try a harder one. We're going to do 4 of these, and then we're going to switch to another topic. Okay, problem 2. Okay? Again, only terms with matching radicals can be combined, can be added together. If the radicals don't match, they can't chill together. So 3, 5, no, there's another 3. So we can combine these two. 4 minus 6 gives us -2 times the square root of 3. And then this guy, he just chills at the end. So that's the final answer there. Wait. Oh, no, that's right. I was looking at the wrong answer. I do that quite often when I just glance at the book to make sure I did the example right. And my eye often settles on the next problem, especially when they're little problems like these, so they're close together in the book. My eye will just land on the wrong one, and I'll be like, I did it wrong. But I didn't. I did it right. All right. And these problems, again, they work very much like, quote unquote, adding like term problems, because John will play games where he'll mix them up and we have to sort through, and we remind ourselves the number on the outside doesn't matter. It's just the number on the inside of the radical that has to match, right? So like this is a 3 on the outside, but this is a 3 on the inside. Those 3's don't have anything to do with each other. We only look at the number on the inside of the radical, and here we have some 2's. And here we have some 3's. So let's combine the 2's first. -3 and -2. Remember, the sign matters. The sign goes along. So that becomes -5 square root of 2. And then we have +5 and +8. That's +13 square root of 3. Okay. Flipping. The next one, it's not really a trick, but it's kind of a fun twist. Add 4 square root of 3 minus 2 square root of 2. Okay, so we stop and take a look at that, and we go 3, 2, and 5. None of those match. What are we supposed to do? And the answer is nothing. That's the answer. You can't do anything to simplify it. I hope you get lots of those in the homework. I don't think you'll get lots, but you might get 1 or 2. Okay, so that is the beginning of our journey into learning how to add radical expressions. There are going to be some fun twists and complications that we encounter along the way that are actually wildly satisfying, and most students think they're kind of fun. So we'll get to that later, but for now we're just baby stepping into this. Part B is something called weighted average. And this is a calculation that every college student knows how to make, because in college, professors often give multiple assignments. They might have a couple papers, they might have some smaller assignments, and then they have a couple tests usually. And what happens is that they assign different weights to different assignments. So you might take 3 tests during the year, say 2 midterms and a final, but the final one might count 3 times as much as the midterm. Or you might have 5 papers that are worth 10 points, and then the last paper, the 6th paper, is worth 50 points. So there are lots of ways. College professors love to do this, where they weight the grades differently in calculating a student's grade. And so students get really good at figuring out, okay, I got an A at that one, but that only counted for 10% of my grade. You know, they can go through these calculations in their heads. When I went to college, back when the dinosaurs were roaming the earth, we had to do our calculations ourselves, right? We would get all of our scores, but we had to know the weight of each grade, and we had to run through them ourselves. I'm pretty sure now most professors have your running calculated grade online. But always check your grades in college. Oh my gosh, you guys, so many times I got grades on my report cards that I knew were too low, and I went and talked to the professors and I got them changed a whole bunch of times. Like, I'm serious, 5 times maybe over the 4 years I was in college. So always check your grades and make sure you're getting the right numbers. All right, let's get into an example instead of me writing chapter 7 of my autobiography for you. Jim's scores were 60, 70, 80, and 90. Boy, he got better as time went on, didn't he? What is the weighted average of his scores if the tests were weighted 1, 2, 4, and 6 in that order? Okay, 1, 2, 4, and 6. So this was the score, and this was the weight. This professor, let's say, is weighting the scores by multiplying them by this coefficient, okay? Looks kind of crazy, but if you, yeah, they add up to 13. That's weird. So how do we calculate his grade on this? We multiply them together, what's called the weighted score, okay? And that means we multiply. 60 times 1, that's 60. 60 times 2, Jackson, how much is that? Yes, 140. 80 times 4, Caleb, that's yours. Yell, I can't hear you. Right, 320. And I'll do the last one, 540. Okay, we add them all up. 6 and 4 is 10, 16, 2, 3, 4, 5, and 5 more is 10. So that's the total points that our friend earned on all of his papers, right? So now what we have to do is divide this number by, this is the weighted score added up. So we want to divide it by the total of the weights. 1, 2, 6, and 4. Those add up to 13, right? So we take the weighted score, the total weighted score, and we divide it by the total weights, which is 13. And that gives us his weighted average score, which we're going to let John do the heavy lifting here, 81.54 if you divide that. Okay, so that means that out of this work he did, you would think his average would be what? 75, right? Halfway in between because his scores were so evenly distributed. But because he did better on the tests that were weighted higher, his score went from a 75 up to a solid 81, rounded to 82, which means he got a B in the class, even though he bombed the first test and did pretty miserably there. Okay, so that is his weighted average score. All right, and then we have one more to do. I think just one. Yes. 65.6. All right, in the graduate level course, Smith R was taking, each of the 3 tests were weighted 20%. Okay, so there were 3 tests, 1, 2, 3, and they were each weighted 20%. And the final paper was, I'm going to write FP for final paper. The final paper was weighted 40%. Oh, that's very, very typical, right? Smith's scores on the 3 tests were 60%, 70%, and 80%. Okay, that looks, I mean, decent. It's kind of low. His score on the final paper was 60%. Ay, ay, ay. He really sucked it up, right? What was Smith's overall score for the course? Now, these are the weights, and these are the scores. Because of the way the problem was given, we got them in opposite order. Last time we got the scores first and then the weights, but it doesn't matter. We're still going to multiply them, and we're going to get our weighted score when we do that multiplication, okay? Now, these are all in percents, so what we're going to do is convert them into decimals. So this one is going to become 0.2 times 0.6, right? I'll do it with parentheses so I don't have more dots floating around, right? Because 20% is 0.2 and 60% is 0.6. When I multiply that together, I will get 12 from the numbers and then 2 decimal places. Okay? 20% times 70% is 0.2 times 0.7. So I can follow my format. That'll be 0.14. All right? In this case, it's 0.2 times 0.8, which equals 0.16. And this one is 0.4 times 0.6. Let's see, that's 24. And then 2 decimal places, like so. Okay? Now, when we add these all up, we will get the weighted score. We won't have to divide this time because we multiplied by decimal numbers that add up to 100%, or when we get them in this format, it's 1.0, right? 2 plus 2 plus 2 is 6, plus 4 more is 10 tenths, and that makes 1.0. So this time we don't have to divide. The way the teacher set it up, the grades will calculate in a simpler way. I don't usually see teachers do this. They usually do this, okay? So now we just have to add these. Let's see, I want to start here. 6 and 4 is 10. 6, carry the 1. 1, 2, 3, 4, 5, 6. So this student got a 0.66, or I'll write it over here, 66% for his overall grade, which kind of makes sense because even though he did better on some of the tests, he really sucked it up on the final paper, right? He did a really bad job. So his grade is going to be it's going to be pulled down by that, right? Okay, that is our study in weighted averages. I hope you enjoyed it. It was really fun for me. That's all. for lesson 65. I will see you again for lesson 66, which is, I promise, is just going to be a gem. Farewell. Goodbye.